Hey everyone, welcome back to Sensor Secrets. I plan on being here every Tuesday, sharing some real world tips from my over 20 years in the sensor and automation industry. Today we're going to talk about light operate and dark operate sensors, sometimes also called light switching and dark switching. These are two essential output functions that you need to understand when selecting and using photoelectric sensors. And stay tuned to the end for a bonus tip, very critical if you're using retroreflective sensors. So photoelectric sensors work by emitting light and detecting its reflection from a target. For more information on how to choose a sensor and the differences between energetics and different proximities and background suppression, check out the essential guide to sensor selection here. Once the target is detected by whatever sensor you pick and it meets the parameters of the sensor for activating, the LED on the sensor turns on. But what the output pin and the wire going to, let's say, PLC or controller does is determined by being a light operate or dark switching, dark operate sensor. In a light operate mode, when the sensor detects the target, the sensor's indicator LED turns on, and so does the output wire. It goes to a high voltage. In short, the output pin is on when the target is present. In dark operate mode, the LED indicator on the sensor does the same thing and turns on when the sensor detects a target. However, this time the output turns off. In short, the output pin is high when the target is not present, and it turns off when the target is present, exactly the opposite of the light operation mode. In this mode, in this dark switching mode, the output is on when there is no target, and the receiver is dark. That's kind of where that's coming from. There's no light coming back. So let's take a look at this in action. Here we have a sensor with a physical light and dark, or an L and a D switch for light operate and dark operate modes. In light operate mode, the sensor LED turns on when the target is detected because it gets light, and also the output wire turns on, and we can see the light and hear the buzzer. Now, if I switch the sensor to dark operate, the indicator LED on the sensor still does exactly the same thing. It activates when the target is present, but the output pin does exactly the opposite. Let's take a quick pause here, though, and talk about why someone would choose a dark operate sensor, as it seems somewhat counterintuitive and backwards. However, dark operate, dark switching mode is often much more fail-safe and is used a lot in control engineering and control design. Let's say, for example, we want to indicate to a machine if a collision is about to occur and stop the movement. If a light operate mode is used, which this is, then the PLC will wait for the output to turn on and to go high before stopping the process and stopping the collision or whatever they're wanting to do next. But what if the sensor lost power, or the output wire broke, or the sensor's damaged? That high signal will never come on, and the collision will not be stopped. On the other hand, if the engineer used the dark operate mode instead, the output would be high all the time when things are good and happy, and go low when a decision has to be made to prevent the collision. In this way, if the sensor is broken or a wire came loose, it will still fail safe. So that's one reason why controls engineers choose dark operate. But now let's look at how that choice is made. Some sensors require you to choose light or dark operate when ordering. We'll take a look at a filter here as you're going through the sensors, and you can pick dark operate or light operate or both. Some models like the G6 have a physical switch to toggle between light and dark. Some sensors like this HTB18 offer both light and dark in the same housing. So we can look at that here and see there's a switching mode is light and dark. We have both of them at the same time, and those are often indicated by these complementary light and dark switching. It is often showed here by a Q and a not Q. Sometimes there's a Q1 and a Q2 like this. Q1 is light switching, Q2 is dark switching. So on the models that have both outputs, the controls engineer gets both, but now has to make sure they choose the right pinout, the right wire, or use both for an even more safe, fail-safe operation, because when one is high, the other one's off. When the one's off, the one's on. So you can look for both of those being on and off. As a quick aside, for non-light sensors, like let's say inductive sensors, the same logic applies, but light and dark can't be used, so kind of old school relay logic is used. And the sensors are marked as either normally open switch or normally closed. It's very similar. When a metal target is detected, should the output close and go high, or should it open up and go low? Same principle, just different terms. So understanding light operate and dark operate, dark switching is key to choosing and wiring the right sensor for your application. Now, for the bonus section. So far, I've talked about light and dark switching on photoelectric proximity and background suppression sensors. That's a sensor that looks at natural targets and relating that output status to a target being detected or not. But what about a retroreflective target that sees light from the reflector when there is no target? It's kind of opposite. So when there's no target blocking the reflector, let's say this is on a conveyor and there's no box there, a light operate sensor will turn on its output when there's no target because it sees light. The output will turn off when the target blocks the light from the reflector. Let's take a look at that. As we can see here, the datasheet's Q1 is the light switching and Q2 is dark switching. So they're both on the same sensor. Let's take a look at Q1 output and the indicator LED on the sensor. When the target is absent and the sensor sees the reflector, the sensor LED indicator is on and the light switching output is on because the sensor sees all of its light coming back from the reflector. However, when a target is present, the light switching output goes off because now it's dark at the receiver. However, you'll notice Q2 at the same time, the dark switching output, it does the opposite and goes high when the target blocks the reflector. So proximity and energetic and background suppression type sensors see light when there is a target, and retroreflective sensors see light when there's no target. So keep that in mind as you're selecting your sensors and your different output modes. So that's it for today's installment of Sensor Secrets. So for more details on these types of sensors, check out my other videos, especially the sensor selection one. It's pretty long, but you can skip through to the different chapters to find the part that's interesting to you and help you get to the right family and the right sensor to test out. So I hope this helps you choose the right sensor for your application. Please hit the subscribe button and come back next Tuesday for more Sensor Secrets. And please keep those questions coming in the chat. See you next time.